So far we've managed to get to this point, so let's see how we got here. Now to the stage of removing this bell housing from the gearbox. What we're going to be doing next is mounting the bell housing to the motor that's sitting in the car. Then we can get our clearance issues for the tunnel, set the depth on how far back the motor's going to sit into the engine bay, also our angles and stuff, so let's remove it, Just notch the gearbox tunnel out. Got the motor sitting roughly into place, give or take 10 or 20 mil or so, just sitting there for the now. You can see it's going to be nice and close against the firewall. Nice and tight there. You can make a relatively biggish tunnel going back towards into the car, so we can still get our hands to get the nuts and bolts off. It's going to be our rough placement. Angle's set to around about 3 degrees for the now. Just need to make sure we can still get our tension on the pulley, so we need to put the belt back on the front pulley and make sure we're not going to be hitting the chassis rail. As you can see, we'll now raise the motor by about 40 mil. And we'll also shift it back roughly around 50. So those dimensions could change. This may come forward slightly a little bit more, and also this may go up or down, but for the now we can sort of start roughing out our measurements for the cross member and the brackets coming from the chassis. Next part is we're going to be reverse engineering this. So what we're going to do is get all the dimensions of all the factory pickup points and how we're going to build this whole new engine bracket cross member type system. It's all going to be off dimensions, so nothing will be built on the car, it'll all be built off measurements. So once it's all done, it'll just be put it up in the car, bolt it on, good to go. Simple as that. So what we're up to now is we're getting all of our datum points and measurements for this new cross member we're going to be making. So we need to find out stuff like the bolt hole spacing between there, bolt hole spacing going across the chassis, where the spindle lands and all those type of things. So it's not as hard as it sounds, so we'll get into it. Here's a pipe bender out here in the ngāhere. Reason being is I didn't want to dyno bolt it into the shed because we've got that shed carpet in there, and when I cut them off I'd probably end up mounting the carpet and whatnot. So at least where it's sitting here at the moment outside, no cars drive around here and no one walks over here, so they won't trip over them, but just a temporary fix for the now. Never used a tube bender in my life, have no idea how to work out where you need to land the bends and all that type of stuff, but no doubt we'll just give it a go. Don't have time to YouTube it, we'll just figure it out by measurement, I think. Here's our first attempt at using a tube bender. Used a bit of schedule 41 inch. I was quite surprised how effortless it was to actually manually pull this around. It actually wasn't that bad at all. I thought it was going to be a bit of a struggle, and I thought it may have ripped the dyno bolts out, but I think the way I set up the stand, I had it really wide, so therefore it's going to spread the load a lot easier on the concrete, and yeah, sweet as, happy as with that. So we're going to use this as a test piece to get our dimensions, because I don't know how to bend it, I don't know where to measure, I don't know where on the pipe I need to start my bend and all that type of carry on, so I thought I'd use that as a test piece, done roughly around a 90, and then get our dimensions off that, and then we can transfer it to the proper bit of tubing, and then we can start making this cross member. Here we have it all marked out on the table, so we're going from this complex style RX2 cross member, the factory one, to a few simple measurements. This cross member we're going to be making is going to be really simple. The main dimension we really got to worry about is where the spindle starts. This one here, that's for our lower control arm. You don't want to shift that any further back or forward. You want that bang on so you keep all of our geometry right. One of the main reasons we were making this cross member, you might have seen in the last video, is this pivot point here. It's going to be raised up a lot higher because before the arms were basically on that angle there, they were touching that, coming down there. So if we shift that pivot point up, that's not going to be there anymore. We'll keep them level, and that should keep everything running nice and true. What we're going to be doing also is we obviously have to make some new spindles, and how we're going to be doing that is we'll get a bit of billet, we'll turn down our diameters, and then we'll be thread cutting, so you might find that quite interesting. Hopefully our little lathe is capable, it doesn't have too much backlash, it's an old second-hand unit, and we'll do a test piece, and if it's sweet then we can do the thread cutting and be good to go. So yeah, we should start folding some metal and bending some pipe and drilling some holes. First I'm using a tube bender, so we've done a practice 90, so we use the test piece first. So I'll do another 90 and hopefully it lands exactly where we want it to. And if that's the case, then we can run with those dimensions. If not, then we'll have to keep fine tuning it until we get it bang on. Here goes our first test piece. We just want to see what formula it took to get these, and as you can see it's still out. It's out by about 5 mil or so. So yes, it's a little bit of guesswork I think. Obviously it won't be sitting that low. You sort of get the idea. Here's the measurements we needed for the mount for the cross member. Transferred it all to this plate. This was a real big piece of plate, and I just cut it out to suit. Now we've got to throw it out to the press and start bending the folds into it. What we're up to now is making the mount for the cross member, so it'll come along there, up there, back down that way. The reason why I want it to raise up near the chassis rail there, so we have a bit more clearance for this arm. As you can see, if it was that we ran a flat plate straight across there, this arm will be all the way down here. So now it's going to have a lot better angle, because you got to remember that this is now suspended, so everything's sitting down. So once the weight of the car goes back on, this arm ends up pushing up. There's a fine line between having it too close to the chassis rail, and then when you lower the car back down, it's going to hit this, or having it too far down there and then the angle's too far up. So once we make the plates, put our cross member bar in, so we can get our spindle exactly where we need it. Hopefully this is all starting to make sense now. Here goes the cross member mount all folded up, 6mm plate. Got the measurements bang on, flush with the outside of the chassis rail, and basically nearly touching that inside pinch line there, so pretty happy with that. We've still got to shape the ends, radius them off and whatnot, but for the now we've roughed it out, and now we can start getting our bars that are going to go across. Sort all that type of stuff out. This is the stage we're up to now, so on the next video you'll see we end up making another hoop that comes across here. The reason being why I want two of them is because I want a lot of support for the spindle. So how we're going to be making that spindle is basically we'll get a bit of stock, we'll machine it down, cut the thread in the end, then we'll drill out this one, the second one that's going to be here, put it through, weld to this side, back side of it, front side, so there'll be 4 welds in total. And we'll obviously add gussets, and then we'll add some string through the middle there as well, some bracing. So we'll touch base on that in the next video.